When you request a web page, your browser doesn't just fetch a single HTML file, it must retrieve multiple embedded objects, like images, stylesheets, and scripts. How HTTP manages the underlying TCP connections to fetch these objects heavily impacts network performance and load times. Let's compare the performance of non-persistent and persistent connections. In HTTP/1.0, we use non-persistent connections. To retrieve each object, a brand new TCP connection must be established, used, and closed immediately. This requires a three-way handshake, costing 1 round-trip time, or RTT. Next, the client sends the HTTP request, and the server responds, costing a second RTT. Thus, every single object requires 2 full RTTs plus transmission time. Mathematically, for an HTML file containing n reference objects, a non-persistent connection requires a total of 2 times n plus 1 RTTs. The first RTT pair is for the base HTML, and the remaining 2 RTTs are repeated n times for each object. This severe connection overhead causes significant latency and wastes server resources. To solve this, HTTP/1.1 introduced persistent connections by default. The server leaves the TCP socket open after sending a response. Subsequent requests and responses between the same client and server can reuse this open connection. Without pipelining, the client simply sends a new request only after receiving the previous response, reducing overhead to just 1 RTT per object. We can optimize further with pipelining. In persistent connections with pipelining, the client does not wait for a response before sending subsequent requests, but rather sends multiple requests back-to-back. The server processes them and replies sequentially. This reduces the total handshake and transmission delay for all n objects down to essentially a single RTT after connection setup. Let's summarize. Non-persistent HTTP/1.0 opens a separate connection per object, wasting bandwidth with double RTTs and high server CPU load. In contrast, persistent HTTP/1.1 keeps the connection active, requiring only 1 RTT per object, or an even shorter time window when using pipelining. Understanding these fundamental mechanisms is essential to optimizing web application performance.